In this video, we're going to go straight into what's called the ambiguous case for the sine rule. If you're not familiar with the sine rule, make sure you've watched a video on that first. So, the reason for this is that essentially there can be two triangles that could be drawn when you're given certain information about a triangle using sine. I'll see if I can explain that. So, when solving for sine on your calculator, or the inverse of sin, there could actually be two solutions, but the calculator actually only gives you the first one. And so to find the second angle that could be possible, meaning there are sometimes there's two ways to draw the triangle based on the information given, we subtract the first one from 180. So that's basically the main thing you need to remember. To find that second angle, you do 100 degrees, subtract that first angle that the calculator gave you. That's how we would find it. Just a note here that sometimes one of the angles can be ruled out when you do this 180 subtract. And the reason for that is if it causes the total angles to be over 180 degrees, obviously that can't happen in a triangle. So in which case there would only be the one solution, which would be the first one your calculator gave you. What I mean by that is if you got the new answer for the second angle and you were to add that to the degrees of the other angles in the triangle and it becomes over 180, then this second option can't exist and we just go with the first one. Just a refresher that we did this example in the previous video, just finding sine rule, and here are the steps that we had here. So we're looking for pairs, the angle and the side pairs, and then we substitute that into the formula. So noticing we were solving for an angle B, and so that was in the top left of what we were of the fraction on the left hand side. We get to this point here, we do inverse sine, and our B value is 39.35. So let's remember that one. We're going to use that on the next slide now. So it's the same triangle. So as I said, angle B was 39.35. Here's this ambiguous case for sine. We have to consider how it could be drawn. So what I'm trying to say is that is it possible to draw this triangle with one angle being 72, two side lengths known of 6 and 4, and then another angle B? And what could the two answers possibly be for B? So the technique that you have to do is you do 180, subtract that first value that you found, the 39.35, and then you write your answer as the second option. But then you have to think about it in terms of, could this happen for the triangle? So now we're saying, oh, maybe that there's a triangle that could be drawn with that as one of the angles, but then have a look at what else we've been given. We've already been given 72, definitely in the triangle. When you add them together, they are over 180 degrees. So it means it's not possible to draw a triangle in this situation with the second possible angle for sine. So let me take you through an example where it is possible. Just to speed this up, I'm just going to use the whole example here as written out in one of the textbooks. So imagine that you can't see the bottom half that's all written out there. And the question says, in triangle ABC, so you're imagining a triangle, ABC, here's some information. Here's a side length of 12, another side length of 8, and we're told that angle B measures 28 degrees. So here's one possible drawing for this triangle, with the 28 degrees here for B. Solving for angle C now. So angle C is over there, using the sine rule, setting it up there, solving for an angle, substituting values in, finding inverse of sine to give us 44.8. Therefore, angle C is 44.8. Using the ambiguous case of the sine rule, the technique is to then try and consider the second angle. And you do 180, subtract the 44.8, and then that gives you 135.2. Could that be possible? Let's consider some other information. We would have to know all three angles in the triangle to see if that's possible or not. 135 add 28, that's still less than 180, so it could be possible. And as the answer here says, in this case there is insufficient information to determine the actual shape of the triangle. Let me see if I can explain to you what that second triangle could look like. So C for the first answer was 44.8. Now if you are familiar with your degrees, 90 degrees is easy to imagine, 45 degrees, yeah, the angle C there, that looks about like 45 degrees. Can I draw you a triangle with 135 degrees at C and still keep some of the other information intact? So what I'm going to do, try and imagine that 12 centimeters, and we're going to move it around to angle C. What I mean by that is I'm now going to try and write an angle of 135 degrees. What is that? 90 degrees is there, 180 degrees is a straight line, and 135 is about halfway between them. So what I mean by that is we've got a straight line here coming out at angle C. What could that be to be 135 degrees approximately? Let's say coming out here. So this is another possible way to draw this triangle with a side coming along here, and then having side 12 come and touch that. So this is point B here. Let's say that that is now about 12 centimeters. Yes, this looks like it could be possible. And then 28 degrees is in there for angle B. So we're saying that there could be a second way you could draw this triangle with 138 degrees, or 135, sorry, 0.2 in there, and the other pieces of information still true. So that's just trying to explain to you how there could be two triangles drawn with the 12, the 8, and the 28. In terms of having to understand this at the Year 11 general course level, which if you're in other states is sort of about the middle level of maths for senior years maths, you won't ever have to prove this. This is for the higher levels of maths, the math methods class, that they would be expected to understand how to construct these triangles and to understand this ambiguous case. At the general level, check with your teacher how they want you to set it out, but usually it's just a case of considering 180, subtract the first angle, and writing the two possible angles, and then just considering if it goes over 180 degrees in the triangle or not, to therefore rule it out. So once you've done some specific examples, check the setting out for that with your teacher so that you're making sure you're doing it in the right way. I hope that helps to explain it. It's called an ambiguous case, and it's an ambiguous, tricky thing to get your head around, so it's totally okay if you're not really sure what's going on here. That's okay too. Clarify that in class. There are the questions to do in the textbook. Thank you for joining me.